So at this point, Joe, I'm going to hang it over to you so you can take the last 15 minutes. So let's go ahead and I'm going to go ahead.
Okay, so if you want to watch the answers questions window, I'll take over the presentation. Okay, so everybody can see my screen?
Yes, I can see it.
Okay. So what I'm going to be showing, so I'm going to be starting with the API or SDK. As I mentioned, when we install RhinoCAM 2023, the SDK will be loaded in this folder. It's automatically loaded. So if you look at program data, Rhino 7, if you go to the plugins folder, and then you go to RhinoCAM 2023, there's the SDK folder here. And under the SDK folder, you're going to have two folders. One is called doc, which is basically the API or the SDK user document. This is where all the documentation for the SDK is present, and you can go through this. It talks about, it's pretty complete, so you should be able to get started with it just by reading this. It talks about both the .NET framework as well as the Python interfaces, and it talks about the dependencies and how you want to set up, what are the tools you want to use for .NET as well as for the Python, and how do you set up the programs. It's got some code snippets that you can learn from. And then also it has a description of all the API methods that you can use. So it's quite comprehensive. And also I should state that this is not complete. The SDK is not complete. It's a work in progress. So we've started it out for a few methods, the more important ones, what we think is more important ones, and also based on user requests. And we keep enhancing this. So if you start using it and you have any specific requests, please send them in, and we'll definitely add it to the list of things for us to do. Okay, so what I'm going to show here is how can we program, using the SDK. And I'm not going to be showing C# in this because it's a little bit more complicated. But anything I do, I'm going to be showing it in Python. Anything that you can do in Python, you can do in C#. So typically when you're programming, I like to keep the window, kind of split up into the Rhino on the left side, and then I have the Rhino edit tool. So if you want the Rhino editor for the Python, Rhino's got a pretty nice editor for Python scripts, and you can access it here under Tools. If you go to Tools and you go to Python script, you can say Edit, and that's what it brings up here. So what I'm going to talk about, I'm not going to be actually programming, but I'll walk through some of the programs that we have created, and that should give you a pretty good idea of how these programs are constructed. The most important thing for a RhinoCAM Python program would be the initialization. So actually what I can show is if you, these folders are, let me go back to the program files folder and the SDK folder. Right, let's go to Rhino 7, plugins, RhinoCAM. Then you go to SDK and you go to the examples folder. I didn't mention, I didn't go into this. So if you go to the Python folder, you're going to have a whole bunch of these examples that you get started with. So what I've loaded here in my editor is a few of these, just to give you an idea of how you can start constructing these programs. The most important one is the API initialization. So this is what I've loaded here, and you can just copy paste this. This is basically importing some of the libraries, the Python libraries the SDK uses. So if I'm going too fast, please stop and put your questions in the questions window, and Don, you can always stop me. Okay, so the next one I'm going to be showing is this, operation. This one creates an operation. It's called mops.py. It basically creates an operation. As we have seen, this does the initialization in this section. And then it uses the tool manager and creates a ball mill. And this is the create ball mill tool that is basically using the SDK methods, and then is setting that as the active tool. And then we are using print statements here, which will actually come out here in the Rhino, command window as prompts. So you can put debug statements in there to figure out what's going on. So, okay, and then we're creating a parallel finishing operation. And then once the parallel finishing operation is created, we're actually modifying the tolerance. We're getting the tolerance and then modifying the tolerance to a certain need. And then we can finally regenerate the tolerance. Regenerate the operation. So this is what, let me show you something. Let me load a file. Let me load maybe one of these files that Don was working with. So we have that file. It's got nothing loaded. So now I'm just going to run this program. So basically you can see it already created this parallel finishing operation, which wasn't there before. So, and if you can open it, if you go to the parameters, it should be 0.02. That's the intolerance that was set down here. So as you can see, this is a level of automation that you can, if you're always using a certain toolpath method, you can set it up this way and machine it. So let me run this again. So in case it went by too fast, I'm going to delete this operation. Let me turn the stock model off. Everybody can see the part. And all I'm just going to do is go and hit this play button. And that's going to create the parallel finishing operation here. Okay, hope that makes sense. And then one other thing I want to do, make it a little bit more, this is a little bit more advanced program. What it does, it kind of creates two operations, creates a flat end mill, and then it creates a roughing operation, and then it creates a ball mill, and then it creates a parallel finishing operation, and then regenerates both of them. And this is a little bit more detailed, and it's got more debugging statements, and it kind of also shows you how to do error handling. So in case a tool failed to create for some reason, how do you want to do the cleanup and exit. So there's a function here that shows how to do the actual cleanup. All of these need to be done in order for it to, these are good programming practices. Okay, let me run that. Let me load a different part. So I can, okay, we got a different part here. Let me turn off the stock model. And I can even delete this tool library. So I got no tools. So it's pretty empty part. All we have is a design. Let's say we want to run this. So I'm just going to hit this. And it's automatically created those two operations, and it created the two end mills. One is the flat end mill and the horizontal roughing, and then parallel finishing. As you can see, if you once you create something like this and set it up, you can run this, in a repeatable fashion, and you can see the speed and efficiency you're going to, encounter in your shop floor when you do something like this. So,
okay, Joe, that's a good point. We got a couple of questions.
Okay.
One is the SDK specific to Rhino and not Visual CAM? Yes, you got to have Rhino.
Correct. That is correct. Yeah, it's only the reason we have done that. It's not available in Visual CAM is because the SDK, the Rhino SDK, is very powerful. So you can do a lot of modeling things, and there's a lot of tools in Rhino that you can leverage, and which we did not want to duplicate in Visual CAM or Visual CAD. So if one of our users is interested in actually doing automation using the SDK, we would definitely point them to the RhinoCAM product and not the the Visual CAM product.
Okay, we also have another question. Where can designers go to learn more about how you can create the Python script with Grasshopper?
I think the Rhino itself, they have a lot of resources to learn about how to use Grasshopper and Python. Python is basically a very general programming language, and so you really don't need Rhino or RhinoCAM. There's many schools out there, many online schools or many online courses you can take in Python. But once you learn Python, get a basic understanding of Python, then you can learn how Python works inside of Rhino. The Rhino has a couple of things that you need to understand how to use Python. There's a thing called Rhino script and Python interfaces with Rhino script. If you can see that some of these, I can show you where the Rhino script is being used. None of these use the Rhino script, but yeah, so there's a couple of subsystems that you need to learn. So once you do that, and then finally you have to come and learn what the RhinoCAM SDK does. So if you're just starting out, you got a long learning process. So, but it can be done. It's not that hard if you have some kind of programming background. So hope that answers the question. The last thing I wanted to show is, again, when we were talking about knowledge bases, Don showed how we can use knowledge bases, and he stepped up the kind of level of automation. One initial, basically loading a knowledge base and machining the part, just but one single button poke. And then he talked about loading the knowledge base and then using selection rules and logic that's built into the knowledge base. On top of that, I'm going to show what's you can actually create an SDK program using the SDK and then load the knowledge base and then regenerate all. This is what this one does. So basically, we're loading a file. Let me open a file. Just a standard file, let's say untitled. So I want to what this program does is does the initialization first, and then it loads a file, and then it loads a knowledge base here, and then finally does a regenerate all. So let's run it. So you can see it takes a little bit of time, so it loads it and it's finished. So this is exactly the same knowledge base that Don was working with. So this is this level of automation. You're not even loading a part manually. You can program all of that. Let's say you have a bunch of design files that your designer is sending you. You can put them all in a folder and set up a program that runs through each of those files, loads them, applies the knowledge base, and generates the toolpath. So it all can be automated that way. And that's a very powerful technique to use in your shop floor.
Mm-hmm. Yep.